So whatever would create that, from just visually inspecting, you would determine that the electric field is strongest here. I don't have to write it out anymore. We can do better. The electric field is strongest. The other way that it can be represented is just basically length of arrow. Same way we've been doing vectors before, longer arrows are bigger than shorter arrows. So sometimes instead of drawing it like this, where you're looking at the concentration, you just show that as you get farther away from it, the electric field just gets smaller. Typically you do it by concentration than this method right here, just because it's a whole lot simpler to draw a single line than a whole bunch of line segments. But the electric field here greater than the electric field here. What do we know about the electric fields created by negative charges? And you just draw lines somewhat symmetrical about the central point until you get tired of drawing them. There's no particular significance for my drawing 5 arrows here and 7 arrows over there, other than I got tired faster here. I sort of think about it like the positive is sort of like a fountain and the negative is more like a drain. So if you think about water being spewed outwards and then circling into a drain, that's sort of the way I think of it. But recognize some implications here. If I have a positive charge here and a negative charge here, positive charge is giving off an electric field. The negative charge is taking in the electric field. But there's a combination here. If I wanted to know what is the electric field at this point right here, I'm not giving you 2 different answers. Because the electric field at that point is the sum of the 2. And what ends up happening is if I have a positive and negative charge like that, the total electric field will start to look like this. Arrows all going sort of around like that. Technically just one out that way and then one this way. And so this is basically what two oppositely charged point charges look like. If they are the same magnitude, then there's a nice little symmetry here. If one is stronger than the others, then it'll start to sort of shift one way or the other, but it is still the same basic shape. And so this is not next week's lab, but the week after that lab, you'll be creating this. You'll have this, in essence, 2 point charges, and you'll be able to map out ultimately the electric field. There's a good chance it will not look as symmetric as it does in the drawings. But it actually comes from rather close. But let's go through the fun little exercise of this right here. So let's come up with some values here. Let's make this 2 nanocoulombs and make this negative 2 nanocoulombs. Let's put the distance between them at 0.3 meters, and this point right here is 0.1 meters from this point to that central axis. So drawing it a little bit more on the clean side. So I got a positive charge, a negative charge. 2 nanocoulombs, negative 2 nanocoulombs. There's a point here. Oh, I guess I need to give one other dimension. This is 0.1 meters, and let's make this 0.07 meters from here to here. Now, just to sort of give you a hint here, you'll be doing something very similar to this on the lab that's in 2 or 3 weeks. As well as, I believe there's a quiz question that will be something like this too. I'll have to double check that. There's one semester where the group had 3 different chances. The last one was on the test, where there was a question like this on the test, which I told them about in advance. Hopefully it won't get to that, so I don't have to ask it. But you will see a problem like this again. All right, so the question is, what is the electric field at this point right here? I'm going to call it point P. Where's the electric field at point P? Well, I have 2 charges here, so I'm going to have 2 electric fields that I'm adding together. So more fun with vectors. What is the direction of the electric field at this point, at point P, because of the positive charge? All right, I got 1 finger in the correct direction, and it wasn't that one.
Oh.
Pointing that way?
Let's look this way.
Oh, that way.
Yeah.
Okay. Sorry, it looked like you were pointing to the.
No. It's
All right. So there are 2 fingers that were pointing in the correct direction, and we just sort of spoiled it because it goes away from positive. So at that point right there, it's going in that direction. Very similar to what I wrote over here. And what is the direction of the electric field at this point because of the negative 2 nanocoulombs? Hey, just like drawn over here. Which one's going to be stronger?
The negative.
Okay. So I'm going to draw that one a little bit longer. I don't have to because I'm basically going to solve it analytically, but sometimes it's nice to have a little bit of a visual. I'm going to call this EP positive, and this one EP negative is the electric field at point P because of the negative charge, electric field at point P because of the positive charge. So the electric field at point P is the electric field at point P because of the positive charge plus the electric field at point P because of the negative charge. This is the math problem we're working with. Our answer is the sum of these 2 electric fields. So what do we do? Okay, what do you want it to be? Somebody's pointing this way. I'm not quite sure. Okay, I just draw an arrow, I'm good.
So we don't know the angle between the 2?
We don't know, that's true, we don't know the angle. Do you want to do that first before the coordinate axis?
I just simply say that because it looks like it could be a right angle.
Oh, this right here? Yeah, assume that is a right angle.
No, the angle between the 2.
Oh, yeah, I'm gonna guess it's not a right angle, but I don't know for sure. Let's finish up this coordinate axis thing. We got this arrow pointing to the right. What next? I can draw arrows in any direction. Arrow pointing up. All right, we're cruising right now. Is that it? Is that how we define coordinate axes?
Well, we need the sense of direction I had, J had.
Okay, which one do you want to make I hat?
The one to the right.
Okay.
It's the positive.
You want me to put positive there?
That's what we usually do.
That good.